We will try to answer today the question, why side-side angle is not a valid test for congruency of triangles. So, first of all, we'll just talk about those that are really tests for congruency of triangles, because it's kind of boring to check whether all sides of two triangles are congruent, whether all angles are congruent, and mathematicians, being lazy people, came up with the shortcuts. Instead of checking all 6 measures of triangle, they try to get away with just 3. So the first test will be the test about 3 sides, which is called side test. That says if about 2 triangles, you know that they have 3 sets of congruent sides, these triangles will be congruent, and so you don't have to worry about the rest of the angles. They'll be automatically congruent. So that will give us side test. The other test for congruency will be the test that allows you to get away with just 2 sides, but you need an angle in between. So about these 2 triangles, you know that these 2 sides are congruent, and these 2 sides are congruent, and also you know that angle between those 2 sides, angles are congruent. Then we can say that these triangles will be congruent according to side angle side test. The third test for congruency of triangles will be the test that allows you to get away with just 1 side, but you need 2 angles in this situation. So if you know about 2 triangles, the following information, you know that this side is congruent to this side, and you also know that 2 angles that include that side are also congruent. Oops. Let me do it better. Those 2 angles are congruent, and the other couple of angles also is congruent. So those 2 are congruent. Then we can say that triangles will be congruent according to angle side angle test for congruency. The question that students usually ask would be the question, how come we can't get away with 2 sides and angle that is not included between those 2 sides? So practically what they're talking about will be whether these 2 triangles that look like this, and that we know about them that these 2 angles are congruent, and we also have these 2 sides are congruent, and sides opposite to the angle are congruent. The question is whether we do have side angle test, or we don't have side angle test. So let's try to see how it works. We will go ahead and try to take an angle, just any angle we want. So that would be the angle, and we will take 2 sides. Oops, I better take 2 sides. So 1 side and the other side, and I'll try to build a triangle that has this given angle and 2 given sides. So to begin with, I'll get rid of these little points that define me the angle. So here is our little angle, and we can make it, of course, as big as we want. And I will try to find the point on this side of the angle that will be making our one of the given sides. So I'll try to build my circle, and here is my intersection, which makes me the first given side. Okay. So now we want to label our points, so I'll label those 2 points as A and B. And so these points define the side of triangle that is equal to the given side that I will also label as AB, because they travel right here. Then apparently these 2 sides, these 2 points should be called B and C, and they will make us the 3rd side of the triangle. So our point C will be somewhere on this side. Let's see whether we can find it. So I will take this side, make it look like this, and I'll try to find that 3rd side of triangle. Right here, this is the circle that has radius equal to BC. I will hide this circle so that it won't mess us up, and I'll make this circle dashed. And I make it thin so that it won't be that obnoxiously bright. So what's happening now? The radius of this circle is equal to BC, and hopefully I should be able to find the side of the of my triangle, the 3rd vertex C, but so far it's not happening. Why it's not happening? Well, apparently my side is not really long enough. So in these situations you can face the fact that this triangle doesn't exist at all. But I can go away and increase my side, and in this case I will eventually receive one triangle or more than one triangle. So let's see how it works. My side C will be an intersection of the circle and this array, so I'll construct those intersections, and I will build the segment that connects the intersection with the vertex of my triangle B. I'll make them more visible, and I'll make them medium, and I will make them solid. And so instead of having one triangle with the given angle A, given side AB, and given side BC, I definitely have 2 different triangles. Are there situations when I have just one triangle where it really does work? Well, apparently if my triangle is right triangle, or if my side BC is the same length than side AB. In this case we have isosceles triangle, which actually gives us additional information. Angle A should be equal to angle C, and let me name this point also with the letter C. If I keep making this side longer and longer, it still allows us to have just one triangle. So apparently this test has different kinds of applications. So let's look a little bit on it closer. So here you have the angle that is given, side C that is given, and side A that is given. If I make my side A smaller and smaller, eventually I lose triangle. I don't have any triangle at all. If I make my side longer and longer, I will end up with the right triangle. And this triangle apparently is unique. So for right triangles we can say that hypotenuse leg test really will work. If you look on these 2 triangles and you put them all together, you will see that all my three triangles will be identical. Okay, so now what will happen if my side becomes bigger, longer and longer? Instead of having one triangle, I have 2 triangles that have the same side C, same angle A, and the same side A, but definitely those triangles are not congruent. So to check whether givens are the same, here we can see the same side C, same angle, but this triangle is obtuse. The other triangle we receive out of this construction will be this triangle that will be obtuse. And apparently our side BC will create with the side AC two different angles. These angles should be complementary angles. So it clearly shows you that sometimes it does work and sometimes it doesn't, and we definitely are interested only in situations where it works 100%. That's why, unfortunately, test side angle doesn't work, and some obnoxious students will call it this way. This is just a joke.